700 astrophysicists, unlimited coffee, and a whole load of science. This is the National Astronomy Meeting. It's the UK's biggest astronomy and astrophysics conference. And this week, I'm not just attending, I'm presenting as well, and you are coming with me. Over the next 2 days, I'll take you into the big plenary talks and the parallel science sessions, including the one where I give my own research talk and support my PhD student giving hers. Plus, I'll take you behind the scenes for the bits you don't normally see, the poster hall gossip, the coffee machine debates, and yes, the fancy awards dinner. So let's go find out what science has got people excited this year and what a day in the life at NAM looks like. My day starts on the train travelling up to Birmingham with the obligatory task of putting the final touches on the talk I'll be giving at the conference while travelling to the conference. The talk is all about my work using the James Webb Space Telescope to hunt for disk galaxies in the early universe. This is such a trope in academia, I know. The more senior you are, the later you leave it to finish your talk. I'm finishing mine on the train. I'm not even that senior. Hate being such a cliche. My talk's not till tomorrow morning, thankfully, so I do have some time, but I shouldn't have left it this late, I know. Thankfully, I got my talk finished on the train, and then I made my way over to the University of Birmingham. All right. Hiya! Oh, alphabetical by first name or last name? First name. Oh, well then am I under R or am I under B? Who knows? There I am. I was under R. Thank you so much. So many freebies this year. I arrived just in time for the coffee break, and I very quickly spotted some old friends and made some new ones who caught me up on what I'd missed earlier this week at the conference. So Josh, what's the most exciting thing that you think you've heard about this week so far?
So it was a great talk from Hugh Lewis yesterday, talking about space sustainability. So kind of scary in a way, talking about like the number of satellites that are being launched in these constellations. It's not really something that I look at all because I'm more of a high redshift person, but yeah, really interesting kind of look at what the future might hold for, constellations of satellites and how things might go wrong as well.
But what was really cool is that somebody gave a talk in the exoplanet session on looking at Venus's atmosphere, which I love because I used to work on Venus, looking at modelling, and some of the modelling could actually be applicable to some of the exoplanet science that we're doing down the line. And coffee's good.
Coffee's always good.
I've always been very fond of the James Webb Space Telescope and the power looking at the early universe, what we call high redshift, to see not only galaxies but also what they're composed of, their elements, and the abundances of things like carbon, nitrogen, oxygen. What's neat about these, they're individual clocks charting the star formation histories, and at high redshift researchers have found quite unusual ratios of these elements which are quite hard to explain.
Really interesting. I'm looking forward to hearing what a lot of people think about that this week. Thanks, Andy. All right, first up on the agenda are the plenary sessions, which are the big high-profile talks that everybody goes to. So let's head in with everybody. So first we heard from Professor Andrew Jackson. He presented his work on how Earth actually generates its magnetic field and how weirdly our best simulations only work by using conditions nothing like in the real Earth core. But he presented his new approach trying to get around all that. Then we heard from Professor Srinivas Kulkarni on how he wants the next big astronomical discovery to come from a small, scrappy telescope rather than the next big flagship observatory. All right. 2 talks done, definitely time for lunch. The joys of the beige buffet of conference food, but lunchtime also means more networking with colleagues, both old and new. If you were going to bet on what the next big astronomy discovery will be, what do you think it'll be?
Some upsettingly high redshift galaxy.
Upsettingly.
Upsettingly high redshift galaxy. Because we keep pushing back to higher and higher redshifts, and it keeps being like, oh, there's mass where there shouldn't be mass. And we keep going back, and there keep being more galaxies. And I think at some point we're going to find something and just be like, why is that there? I think that's my best bet.
Nice. So unexplained, confusing, all the things you want.
The high redshift universe is weird. Yeah. I think it's going to be something, we're going to find some weird blob, and just everyone's going to be scratching their heads going, why?
Love it.
We've been seeing in time domain these little red dots, and I can't speak about what they are at all, but I think they're very interesting. So, yeah.
Very cool. NAM also brings collaborations together, and ours was no exception. So my PhD student has just heard back from the referee of her research paper in like the peer review process that all papers go through. So a few of us sat down to discuss the plan going forward and what work still needed doing to address the points the referee raised. All right, it's time for my first parallel science session. Because there's so many people who want to present the research work they've been doing, there's multiple sessions on different topics going on at one time. So for example, this afternoon, there's a session on exoplanets going on at the same time as a session on solar physics. But I went to the galaxy evolution session, where we had some really interesting talks on the environment of a galaxy. So whether a galaxy is surrounded by other galaxies in a very dense environment, or it's left isolated in an underdense environment. And a lot of the talks were about how that environment affects how the galaxies evolve. After this round of talks, there was thankfully another coffee break.
Be honest. What number of coffees have you today?
Coffee, this is one, but I've had 2 energy drinks, so yeah.
Oh, this has got to be, I don't know, number 3? Yeah, it's what fuels me.
What number of coffee is this for you?
Okay, this is number 3, which I think is okay. I think that's not too bad, actually.
Pretty good for you.
Yeah, it's only like lunchtime. It's fine.
3rd. And I think I'm gonna get to 4th as well, because I'm a bit tired from all the week. It's been great, the conferences are great, but yeah, I'm really a bit tired as well. So 4, the average is gonna go to 4, yeah.
Then after the coffee break, there were more of these parallel science sessions. Annoyingly, there's 2 that I really want to go to that are on at the exact same time. One on galaxy evolution and one on the growth of supermassive black holes, which is the 2 fields I work in. So I started off in the galaxy evolution session for a talk on galaxy quenching, or what causes a galaxy to stop forming new stars. And then I decided to hop between sessions. So I left this room and legged it over to a different room upstairs where the other session on supermassive black hole growth was happening. In this session, there were lots of talks on whether there's actually a limit to how fast a black hole can grow. We've always thought there was a limit, but JWST has been finding lots of black holes in the distant universe that seem to have grown too massive in too short of a time, breaking that apparent limit. This was the last session of the day, and afterwards I checked into my hotel. All right, it is about 6:30. My head already feels like it is absolutely crammed with information, and I've only been here 1 day, not 4 days. Like a couple of people. I've come back to my hotel room to just get quickly changed before the fancy awards dinner this evening. I'm in the dress I always wear at conference dinners because you can pack it easily in a suitcase and it doesn't get creased. It's from Reese ages ago. It's like laser cut, which I really enjoy. Big conversation starter as well for an awards dinner. Speaking of conversation starters, I'm gonna get changed some of my earrings and stuff and jewelry as well. I brought my satin earrings. You know, when you're at a table full of physicists, you want a little conversation starter, you know? She's not just smart, she's street smart as well. Once I'd done hair and makeup touch-ups, I was ready. Feed me. So I headed over to the Great Hall on campus for the dinner. The awards dinner is a really fun night to chat with old colleagues and friends and make some new ones too, and of course cheer on those who have won awards, whether for their science research, their astronomy outreach efforts with the public, or their efforts in education. So that means there's lots of toasting to people all around at these dinners. Which means the next morning finds me slightly bleary-eyed doing my makeup to try and make myself look a bit more presentable. Talk day! Yay, this one's gonna be full on. I'm gonna practice in a minute, just have a final run through. What's the saying? Like, if I had a nickel for every time I'd been scheduled to give a talk first thing after the conference dinner, I'd have 5 nickels, which is not a lot. But it's weird that it's happened 5 times. So in order to rally, I made sure to practice my talk twice before grabbing breakfast, just to make sure it was under my allotted time of 10 minutes. With that done, I headed back to the venue for the first parallel science session of the day. All right, John, you're the first talk of the day. How you feeling?
Feeling all right, yeah. I just need to put my bag down. I've not had a coffee this morning, but, you know, so I'm going in cold. And I'm talking about anisotropic quenching for the first talk of the day. So hopefully that's exciting.
Definitely. John's talk was all about how galaxies in big clusters were more likely to be quenched, i.e. have stopped forming stars, if they were aligned with the galaxy at the center of the cluster. After that, though, it was my turn to present. Thank you. All right, since I have less than 10 minutes this morning, I decided I'm going to give this talk backwards. And I'm going to start with my conclusions while you're all paying attention and I have the time, so that you leave with my 3 main takeaways as the first thing you see. So, with the Galaxy Zoo and Sears teams, we have found 839 featureless disk galaxies out to redshift about 7.5. That's a fraction of disks at around 70%, and we're pretty sure they're both disks and featureless, at least half of them anyway. That suggests that dynamically cold disks are in place by redshift of 7. Why that is the case then is really interesting. We can draw on simulations. They suggest that gas fraction in galaxies does play some role, but that seems to be secondary to the dark to baryonic mass fraction. It's only when baryonic matter starts to dominate do features like bars and things like that form. So I was speaking in this session because you find disk galaxies in isolated environments, and these featureless disk galaxies specifically that we found in the early universe using JWST, the James Webb Space Telescope, are really weird and interesting, and it suggests that disk galaxies existed way earlier in the universe's history than we ever thought. Those of you who've been following me for a while might remember that I made a video last year explaining my research on this when my paper was published. I'll link it below if you want to know more. So with that done, it's a huge sigh of relief and I can enjoy the rest of the talks in the session before the coffee break. All right, talk all done. Time for sweet treat, I think. Let's go see what they've got. Cookie. So I have a bit of time this coffee break. I'm gonna go in the hunt for posters. You know, there's not enough time for everybody to present in a talk, so a lot of research gets presented in poster format instead. What have you found? What's your poster on?
So my poster is on investigating really small galaxies in the universe called dwarf galaxies. They are really, really small and faint as compared to like your big Milky Way galaxy. So I'm studying this relationship as a whole. It is called mass-metallicity relationship. So we expect the metallicity to increase as the mass is increasing. However, towards low mass, and you'll see that there are a lot of rebellious dwarf galaxies which have a very high metallicity for a small mass.
So this is lots of heavy elements in the galaxy.
Exactly. Yeah. So I study it using a combination of both simulations and the observations, and the answer comes from both of those. There are answer using mechanisms like tidal stripping, and also with simulations giving the answer of the enrichment of these galaxies due to their environment, density, mergers, and all of these things.
Nice. I had so much fun chatting to people at their posters. I honestly think this is one of my favorite parts of a conference. All right, time for another plenary. It's going already. Turns out before the plenary, there were some big thank yous to all the organisers of the conference and the University of Birmingham, which was lovely to see. Then it was time for 2 more plenary talks. First up from Leah Morabito from Durham University, who is using a new generation of radio telescope to separate the light from black hole activity from star formation in galaxies, all to try and pin down how growing supermassive black holes actually shape their galaxy. And then the second plenary talk was presented virtually by Marcia Rika from Arizona, who is the lead scientist on the NIRCam instrument on JWST, the thing that takes the majority of the images you see from Webb. She spoke about the history of the development on JWST and the unexpected galaxies that it's found at huge distances, like a galaxy that we're seeing when the universe was only 700 million years old that somehow got more carbon than our models say should be possible. Next up, it's lunchtime with another beige buffet. I was very sad to see there was already a huge queue, but I did manage to grab a quick bite of more conference food. But of course, there's no rest for the wicked, because along with focusing on science this week, I'm also doing some media interviews about my own work and about the conference as well. Plus, this lunchtime, I also caught up with an old summer student of mine, Jonah Powley, who's now a PhD student in Cambridge. He was showing me his latest research on the kinematics of the speed that stars are moving and the star formation rate in a distant galaxy observed with JWST. All right, it is the last parallel science session of the day, of the week even, which means it is my PhD student Sophie Jules' turn to talk about her science. I'm going to see if I can find her before it starts. She's around here somewhere, I think. It's you next, isn't it? How are you feeling? How are you feeling?
I'm feeling okay. Yes, I'm feeling okay. A little bit nervous, but I have presented this work a couple of times now, so that definitely helps. But yeah, it's a slightly different group of people, a different area of specialty than I'm used to presenting to. So it'll be interesting to see like what questions people have and what their reaction is. So yeah, I'm looking forward to it.
You've got this. You've got this.
I'm here to talk to you today about the role of secular supermassive black hole growth in driving galaxy black hole coevolution. And in this context, secular growth refers to the long-term steady growth of the black hole during quiet periods in a galaxy's merger history.
Sophie Jewell has been working on the growth of supermassive black holes in bulgeless galaxies, so galaxies that have never merged with another galaxy, presenting their correlation between black hole mass and galaxy mass for what is now the largest number of disk galaxies that this has been plotted for. Sophie aced it. Of course she did. The last talk of the day that I caught was this one from Lucy Ivy from Cambridge about the little red dots that JWST has found in the distant universe. If you've been around on my channel for a while, you'll have heard me talk about this new discovery a few times now and how we can't yet explain them fully. But we think they're growing supermassive black holes. So this talk once again noted that simulations cannot match the observed properties of this specific little red dot. So just another piece of the puzzle when it comes to explaining little red dots. Sophie nailed her talk, which I knew she would, and that means it's the end of NAMM already. I'm gonna be honest with you, absolutely exhausted. I'm ready to go home, but I'm also absolutely buzzing as well, and it's not just the caffeine. I've been so inspired hearing about all the research that my colleagues are doing. I've got so many ideas that I'm gonna take back to the office with me and see what research projects come out of that too. Honestly, being in a room with my colleagues, just getting to chat about galaxies and black holes and the evolution of the entire universe is such a privilege. And honestly, sometimes there's no place I'd rather be. Alright, I am back from NAMM and I've had the weekend to recharge batteries, but before we get to the bloopers, I just want to say a big thank you to this week's video sponsor, Brilliant. Because I know that many of you watching will either be parents with kids who want to become scientists when they grow up, or perhaps are students themselves just starting on this learning path. And the question I get asked so often is, how do I help kids, or how do I help myself learn all of the knowledge that's needed? And honestly, the answer that's backed up by the most research is good one-on-one tutoring, but let's face it, it's just not realistic for most families to source a tutor, pay for a tutor, and also make the scheduling work. But that's what Brilliant have built with their AI tutor, Koji. Koji doesn't give you the answer when you're stuck on one of their courses. It asks questions and walks you through it just like a real one-on-one tutor would. Koji gives you a clue to help by pointing or sketching and stays right there with you through every learning course that you take. I need some help.
Let's work through this together. The truck starts at the top left and moves east first. How many blocks east does it need to go to reach that first package?
I really wish this had existed when I was a student, because I remember so many hours where I was just stuck on a problem with no one to ask. So if you've got a kid in grade 5 all the way through college, you should definitely get them to give Brilliant's courses a try to see how much they learn and where in life it might take them. So you can click the link below or scan the QR code on the screen to get started with Brilliant's tutor for free. You can upgrade to premium to unlock all the courses, and right now viewers of my channel get 20% off an annual subscription if you head to brilliant.org/Dr. Becky. So a big thanks again to Brilliant for sponsoring this video, and now roll those bloopers. Oh my gosh, I've never seen anyone wearing one in the wild before.
David, by the way.
Hi, nice to meet you, Dave. Yeah, nice to meet you. This is so cool. My sister designed these, so she's going to be so excited that you've got it on. That's amazing. Oh, raisin cookies. I thought they were chocolate chip. So sad.
Don't you have people to do this for you, Becky?
No, I'm not as cool as you. This is the thing about vlogging, you have to go and run up the stairs twice. Hang on, I'm trying to get that on.